So now this afternoon, we will be more focused on the GRAPHIA project, and to start this this new series of workshop, we would like to share with you some details about the knowledge graph. What is a knowledge graph? How we can use it, and how we can build it, but through a kind of interactive session. So the idea is to share with you some real example, live demonstration, and to discuss it together. This session is a continuation of our June webinar, but this time we will go hands-on. So it's not we will deep into the details, but also we take the time to break things down, to build together a simple knowledge graph, explore some real-world tools, especially if we want to expose the content of the knowledge graph and address your question. So this is the main idea. So if you have already participated in this webinar, don't worry. We will discuss about new things and with a strong objective for me, which is to make this concept tangible and usable in your own context. So this session is divided in three main parts. First of all, what is a knowledge graph? I think it's important because we will discuss about it during the next workshop. How to build a knowledge graph, the second chapter, and then we will see how to explore all of them. But again, just before, I will ask you some questions. I need your help to understand better what is your proximity with this concept. That's why, please join the mirror board, and you will see a first table with two questions to start this session. I mean, I would like to know how familiar are you with knowledge graph? This is an open question. And then, what is the first word or idea that comes to mind when you hear knowledge graph? So I will let you 3-4 minutes to put some stickers, and then we will review it and we will start to review in details the knowledge graph concept. Thank you. Okay, so some comment about it. As we can see, we have already some result for the poll, and just only one vote for the answer new to it. So we are more or less already aware about the knowledge graph. Some of you are already expert, I guess. But yeah, we have already some concept in mind about what could be a knowledge graph. To better understand what could be, in fact, a knowledge graph, according to you, we have some proposal. Knowledge graphs are related to ontologies, also with linked data and knowledge. We have also mind map, so some semantic concept, but we have also some structure concept, I mean connections, links, relations, complexity of connections, and also we have some references, OpenAlex, OpenAir, so some well-known graph for some of you. Okay, so as we can see, we have all of us more or less some example in mind when we are talking about knowledge graph. So the purpose of this section is to clarify the boundaries of what is a knowledge graph and how we can use this, how we are trying to build a knowledge graph in the GRAPHIA context. And also it will be very useful to have these ideas in mind because we have another session dedicated to the GRAPHIA ontology just after. And tomorrow we will also discuss about how we can talk to our knowledge graph thanks to the last LLM approaches. But that's why the idea is to be on the same page about all the concepts related to the knowledge graph. So now I will share with you some example to clarify a little bit what could be a common definition of a knowledge graph. So you may not realize it, but you have actually seen a knowledge graph many times before, even if you didn't call it that. So let's start with something super familiar, Google. When you search for someone, like in this example, Ada Lovelace, you don't just get a list of blue links anymore. On the right side of your screen, you have also a little box with their portrait, her birth, some dates, some other dates, main achievements, etc. This is not a Wikipedia page copy-paste, it's the Google Knowledge Graph at the core. So a network of facts connected together in order to produce this overview. Then we have also Wikidata on the right. Here you can see Beethoven, and each piece of information about it is expressed as a statement. Beethoven, instant of human, Beethoven, place of birth, born, etc. I will share with you. We will explore Wikidata a little bit more in a few seconds, but the idea here is each fact is not just written as a text, it is linked to other entities in the graph, and it's referenced. That's how Wikidata can connect Beethoven to his works, his teacher, the cities where he lived, and even to the categories of music he influenced, for example. So whether you have noticed it or not, these knowledge graphs are everywhere. But we can also mention some other examples. Here we have also OpenLX, already mentioned in the stickers. If you are searching for a scientific article here, what you see on the screen is more than just metadata. Behind the scene, OpenLX maintains a graph of authors, publication, institution, and citation, all connected. That network allows you to move seamlessly from a paper to the people who wrote it, to the institutions they belong to, and to the work they cite. That is not just a database, that is a knowledge graph for open science. But we can also find some other knowledge graph in the industry, for example. Here you can see a knowledge graph from Siemens. Siemens, in that case, uses knowledge graph to model and trace the entire life cycle of a product, from the design phase to manufacturing to maintenance. And each component, each process, each dependency is part of the graph. Why? Because a graph makes it possible to reason over traceability. If a part is faulty, you can immediately see which system and product are impacted. This is the main idea behind the structure of the graph in this example. And then another example, you have some tools like Neo4j. Here we see the famous movie demo from Neo4j, a network of actors, directors, and films and movies. Notice something important through. Sometimes people call this also a knowledge graph, even if there is no ontology and no semantics, just node on edges. And that is where the discussion starts. I mean, is every graph a knowledge graph? Or do we need more than that? So we will try to explore a little bit more what are the different layers included in the knowledge graph. But also between us, we have some discussion about it, especially from a technical point of view. But at the end, we have some agreements between us. So maybe I would like to illustrate a little bit more what is Wikidata, because it's one of the famous knowledge graphs we have around the world. So Wikidata is not Wikipedia. Okay, Wikipedia is about long-form text and article, while Wikidata is about structured facts. Think of it as a database that sits behind Wikipedia and many other projects. Wikidata was born in 2012 as a project of the Wikimedia Foundation, originally to centralize interlanguage links between different Wikipedia editions. It's a collaborative and multilingual design. And technically, Wikidata is powered by RDF and Sparkle, some concept I already mentioned this morning during the LUMIS sessions. So that means it is not just a giant wiki, it's a fully queryable knowledge graph. So it's open and interoperable, and it connects to countless other datasets. So today, Wikidata has become a backbone of the web of data. You will find it powering not only Wikipedia, but also Google, some voice assistants, digital humanities project, some institution, and even AI tools. So in many ways, it is the most visible public knowledge graph in the world. That's why, for me, it was important to mention it today as a key reference for us. So when we talk about a knowledge graph, we are not referring to a single and fixed concept. Instead, the term covers many layers of meaning. It spans technical models, semantic strategies, and application context, and this is both of strength and challenge. In practice, the expression knowledge graph can point to very different things: a conceptual model, a data structure, a set of technologies, or even a broader strategy for integrating knowledge. And we have already seen it through the different stickers collected for the question about one word to describe what is a knowledge graph. That's why the term is so widely used across multiple domains, from AI to information systems, and from ontology, but to also property graph like Neo4j. This plurality is powerful because it allows different communities to use the same concept, but it also generates ambiguity. That's why the research community has tried to provide clarification. Widely adopted reference from Hogan and colleagues in 2021 defines a knowledge graph as a graph of data intended to accumulate and convey knowledge of the real world, whose nodes represent entities or concepts, and whose edges represent relations between them. This is an adopted reference. And if we look at how this is categorized in the ACM taxonomy, we see that knowledge graphs sit at the crossroad of AI, databases, and information integration. And that is exactly why the notion remains so flexible and sometimes a bit ambiguous. But before we dive into knowledge graph in details, let's step back and ask, what is a graph really? At its core, a graph is just a shape, a structure, with nodes and edges. So entities and relations. This is the same. It tells us who is connected to whom, but nothing more. A metro map, for example, a protein Could you mute the mic, please, online? Thank you. For example, a metro map, a protein interaction network, or even your LinkedIn contact are all graphs. But by themselves, in fact, they don't carry meaning. So graphs are everywhere, but they are not always about knowledge. If I tell you that, okay, A is connected to B, you still don't know what A or B represent. Are there people, data set, dogs? Okay, so without context, a graph is just a structure, no semantics. A knowledge graph goes further. It adds meaning and identity. It tells us what each node stands for and what each edge represents. In short, it's a graph that actually knows what it's talking about. think of it this way. A contact list with phone number is just a graph. But a CRM that knows who the customer are, their history or their intent, that is a knowledge graph. A movie cast list is a graph, but a semantic graph that knows who direct what, which genre, and when the film was released, that is definitively a knowledge graph. Let's zoom in on a concrete example. Matilda, for example, has the objective of this graph is to unify and enrich scholarly metadata. And it's not just about citation count. Every element is type. We have works, author, and text. Relations are meaningful. A work cits another. An author writes a text is part of a larger work. These are not just connections, they are structured semantic links. That is what transforms raw metadata into a knowledge graph. A graph where connection are type, meaning is explicit, and knowledge can truly be integrated and reused. So let me give you a quick demonstration of what makes Matilda a real knowledge graph and not just another database. So I will share with you my browser. Just 1 second. Okay. So, will you see it? Yes, perfect. So if I try, I will see. Okay. So here we start with a search. So Matilda is. I will put it in English. Okay. So we will search among some works through the different open academic knowledge available through this platform. Okay. So I will, for example, search for renewable energy micro algae. Something like this. Algae. Okay, so I'm looking for this kind of publication. So through more than 100 million of works already available. I would like to sort by most cited work, for example. And here, what I see is not just a flat record. It is a work node with identifier like DOE, title, venue, for example, this one. So as you can see, okay, we have already some metadata, but we can already explore the graph because we know that some publications are related to this entire work. I mean, okay, we are able to identify some version of this work through different platforms, and we are already in the graph. We are exploring behind a graph with some relations. And for example, here, you can see the work itself, the author, the journal, and even through the different text version. And behind, the relations are explicit. We are exploring some relation like is author of, is part of, published in. This already goes beyond the metadata. We can see the metadata, but to build this page, we are using a graph. And look at the citation. Here, we can see what are the citations of this document and who are the resources which are currently citing this work. So as you can see, for example, I can explore the graph. Okay, I will open this other work, and then I will also have other citation, and then I will explore the graph like this, citation by citation, and you can see the power of the structure. I mean, it's only from a technical point of view, relation between this object to follow the graph, not only from a search engine approach, but also from an exploration graph strategy. Just to illustrate what could be the feature behind using a knowledge graph. I would like to here explain, to focus a little bit more on semantics. Okay, so raw data, we have at the top, at the bottom, sorry, raw data. But in this layer, it is the unstructured text, the scattered metadata, the isolated dataset. It's fragmented and very hard to navigate. And the idea is to explain why we need semantics here. So here, as you can see, we need to add an extra layer that gives identity to the node and interpretation to the links. That tell us not just that A is connected to B, but whether A is a person, an institution, or a dataset. So as you can see, to build a graph, as I already explained, we need to put some relation through the raw data. This is already a first step of our work, and it's not easy to do it. We have to identify how we can link the concept together, and then we have to put some semantics on top of it through vocabularies, through ontologies, and that's why sometimes, okay, we just need a graph to explore it, but if we want to share meaning and to reason, to infer new information, to extract relevant fact from the graph, we need the last layer, which is the semantics. And these three layers together are part of what is a knowledge graph. And thanks to the knowledge graph, we are able to address different kind of problems, real-world problems, I mean. So first, we can, for example, here, the problem is, okay, I can't connect my dataset. So the idea behind is to use the knowledge graph to provide a common model to interlink and query them together without rewriting everything. So we can have some application directly in medicine. We have some huge knowledge graph in biomedical. So it's an important use case, but not only a public use case. I mean, we have some concrete application in the industry. But we can also mention the disambiguation use case, which is also a problem solved by the knowledge graph approach. Also, the knowledge graph helps us to support semantic discovery through different concepts, synonym, and similarity, and some other example based on this approach. The only message I have here is to say, thanks to the graph and the knowledge graph, we are able to explore new use cases, new innovative way to explore knowledge. And this is exactly the purpose of GRAPHIA. The main objective for us is to offer a new way to discover the knowledge through the SSH concept, but from a graph structure point of view and the knowledge contained in the relations and the entities. So just some word about the rise of knowledge graph, because this is a trend now. In 2025, we are no longer talking about a niche technology. The market is already worth over $1.1 billion and could reach 3.7 to 7 billion by 2030, depending on the source. Annual growth rates are steep between 17% and 36%, meaning the market could more than triple in just 5 years in this domain. North America is leading the way in adoption, but uptake is rapidly growing in Europe and Asia Pacific. And it's not just hype, because Gartner placed knowledge graph on the slope of enlightenment in the 2024 hype cycle. I think that we are past the buzz into a real adoption around the world. So what is driving that growth? Of course, we have AI and all the components related to these new innovative approaches. We will discuss it in details tomorrow. Then we have enterprise search and QA systems, which benefit from semantic precision thanks to the knowledge graph. The supply chain intelligence also, where graphs help trace and optimize complex flows. And also we have a digital asset discovery, especially in science, media, and finance. So in short, the knowledge graphs are no longer experimental. They are becoming a core layer of value in today's data infrastructure. So yes, knowledge graphs are on the rise. We see growth, use cases, market traction, but let's not forget where this all began. Before knowledge graph became a business buzzword, they were already quietly transforming academic knowledge. So that's why I would like to introduce you to the academic backbone of this movement, the infrastructure, the project, and principles that have been shaping how we organize scientific knowledge long before the market caught up. So first, we have open citation, of course. It's an open infrastructure indexing millions of citation links between publications, with the goal to replace proprietary citation databases. We are often closed and expensive, with fair, machine-readable, and transparent alternatives. Next, we have also OpenAir Graph, which is a large-scale research graph that interlinks project, dataset, publication, organization, funders across Europe and beyond. It's not just a repository, it's a core infrastructure for EOSC. So this initiative shows that the knowledge graph movement is not just commercial, not at all. It is also deeply rooted in the open science ecosystem, with long-term impact on how research is produced, connected, and reused. Of course, we have also Wikidata. We already talked about it. Then we have another example, which is the Open Research Knowledge Graph, ORKG. Unlike traditional databases, ORKG focuses on the semantic content of scientific papers, not just the metadata. This makes it possible to compare research contribution, hypotheses, methods across papers, and to support more meaningful discovery and synthesis. And one last example I would like to share with you today is CSKG 2.0, which is a large-scale knowledge graph focused on computer science literature with over 24 million entities and more than a billion RDF triples. It's a powerful tool for trend analysis, citation networks, and meta research. So together, this initiative shows that academic knowledge graphs aren't just about open data, they're about redefining how we represent and compare scientific knowledge itself. So that's all for the first part of this session, to explain, to dive into some example and explain what are the knowledge graphs. So now, again, I would like to ask you 2 questions through the Miro board. So please join the Miro board, and I would like to ask you question 1.3, which of these academic knowledge graphs seems most inspiring as a model for GRAPHIA? And my last question is, what do you see as the biggest challenge in building a knowledge graph like GRAPHIA? In order to introduce the second part, which is, okay, now we will build a knowledge graph together. So I'll let you 5 minutes. Thank you. Okay, so about the third question, which of this academic knowledge graph seems most inspiring as a model for GRAPHIA? Some of you are mentioning Wikidata. We have also OpenAir, Wikidata for SSH, okay. Google Knowledge Graph, GRAPHIA, OpenAlex also mentioned here. Maybe ORKG also. Okay, and then about the second question. What do you see as the biggest challenge in building a knowledge graph? So, data acquisition platform. Yes, it's a technical challenge. We have a lot of discussion during this IPL with the technical teams to define how we can do it. But yes, it's ongoing. Then we have also long-term sustainability, a recurrent question we have. Granularity of concept, data acquisition and disambiguation, of course. entity disambiguation, again, for example, author names, user understanding and comprehension, yeah, about the main objective behind the knowledge graph, making it user-friendly for a broad range of researchers to make it accessible to as much of the SSH community as possible, handling different types of data found within the SSH community, many different UX and UI challenges. We will discuss about it during the third chapter. And yes, so thank you for this feedback. Before to start the second chapter with a more interactive session, because I will share with you a live demonstration, we will build together directly with the external tools a knowledge graph. I would like to know if you have some question, comment, something to add.
Thank you, Julien. Yes, I have one question actually, because so you ask us what are the biggest challenge, and I would like to ask you what are your most urgent needs to build this knowledge graph, and where we can maybe help, or how can we find resource, or yeah, so what are the needs to build that tool?
Thank you, Suzanne. It's a very concrete question. So indeed, we have already mentioned the data acquisition platform. This is our main priority for the moment, because we need to rework the current workflow we are using for GoTriple in order to build the knowledge graph for GRAPHIA. So we have a lot of workshop with PSNC, with all the members of the Work Package 2 involved in this task. So this is our main priority for the moment, but we are already working on it. So we have to find a solution. We have to take a decision. That's why we are doing it during some diners during this week, during the lunch too today. But we will find an agreement together, I hope. And then we have also the GRAPHIA ontology, but that's why we have a dedicated session in 1 hour about it. So it's under control. But also we have some action plan to be able to do things in parallel. I mean, having some enough space to think about our GRAPHIA ontology for a middle and long-term perspective, because we want to be compliant with the other framework in our ecosystem, but also we need to define our model in order to be to not put the ontology on the critical path of the development of the data acquisition platform. That's why we are working on some pragmatic action plans.
So thank you, Julien. So if I understand well, that means that currently you have specific needs, but all the needs are really related to the partner involved in the consortium. So is there any needs in terms of onboarding community or involving them in testing or things, maybe not now, but or do you have enough within the GRAPHIA consortium, for instance?
For the moment, for me, we are already managing it with the involved partner. Maybe we will extend the discussion next year when we have to be more compliant beyond the knowledge graph. But for the moment, we have some technical issues or decision to take together, but internally. So we need more time to do it, but it's directly related to the work in the different tasks, mainly from Work Package 2, but not also, because we have also some important dependencies with Work Package 4 about the different AI modules we want to build on top of the graph. So we have to anticipate things, but we have to find a way to to put already some data in a first version of our graph in order to allow the Work Package 4 to use this data in order to build LLM models on top of it, in order to try to prototype what we want to develop in terms of AI solutions. But also we are working a lot with Work Package 3. I don't know where is Giovanni, but we have already performed some meetings with the teams involved in Work Package 3 to identify what are the needs, what are the interaction between the use cases and the pilot with the knowledge graph. So we have already more or less the big picture in mind. So now We just have to prototype and to start the development. This is our main concern for the last part of this year. Any other question? Maybe online?
Julien?
Yes?
There was a question in the chat.
Yes, please. It is also a knowledge graph, right?
Yes.
So we are talking about Nomad Lab. Okay, so I don't know. Maybe some maybe on site you already know this one. Personally, I don't know Nomad Lab, but maybe you have already.
I'm familiar with this work from another context, from my previous job, and I just wanted to understand if this also qualifies as, you know, if it's built on a knowledge graph or not, because you can effectively, I think it has a distributed way of working with the Nomad, with some software of open lab notebooks, where you can then input your information from your local lab into this platform, and I assume there is some sort of data, you know, some sort of mapping relationships that you have to, you know, align before you can update things in the Nomad. And then within this platform, you can also analyze things, and you can see that there is also opportunities to do some analysis with the data involved in this. Just as another example, if you want to look at it and if it would be useful, that's why I only shared it. Thank you.
Thank you for this. And it's also an opportunity for me to explain another important part of our knowledge graph is to be able to build some bridges with the other knowledge graph if we need it. That's why Work Package 2 is working a lot of the framework on top of the ontology to be sure that, okay, we are compatible with the other knowledge graph, because this is a philosophy behind a knowledge graph, to be also compatible with the other initiative in our ecosystem in terms of interoperability. That's why we have the work currently done by Jan and Work Package 2 through task 2.1, and he will share with you more details in 1 hour. And then we have also all the work performed through the Atrium project with Go Triple, where we are trying to extend the Go Triple ontology to be more semantic oriented, I mean. So this is all the work currently performed also by Net7 through the Atrium project and the other members of this task. Okay, so if we don't have any other question, now I will share with you again my slide. Okay, so now, very quickly, I will introduce you how to build a knowledge graph, but we will do it together for real. But just before, I would like to explain a little bit more. I would like to focus a little bit more about what we have to develop when we are building a knowledge graph. So, okay, initially we have raw data, as we have seen before. So we have to, first of all, identify how we can put some consistency, some meaning into our knowledge graph. So, as you can see, in the different layers, we need entities, I mean the nodes. We need also relationships, the edge, in order to link the node together. But also we need the semantic layer, so the ontology, the meaning, the rules, how we can explain what we have in our knowledge graph. So, in GRAPHIA, we are trying to do all of them. We have to translate the data we already have, the data we will collect through the use cases, through the pilots, into triples, into nodes and entities and relationships. But also, we have to build our ontology and to identify how we can connect the two layers together. This is what all we had to do through GRAPHIA from a simple perspective, you know. Also, I would like to share with you this slide because we have to talk about the solution, the technologies behind a knowledge graph. And as you can see, we have different knowledge graph active players to watch. So this landscape brings together a variety of actors, from enterprise giant to niche innovators, each playing a distinctive role in the development, scaling, or specialization of knowledge graph technologies. We have the semantic web veteran, like Ontotext, the semantic web company, and also we have France Inc. with Allegro Graph. Each playing which playing in the RDF scene for over a decade, focusing on reasoning, linked data, and standard compliance. Just now, GraphDB from Ontotext and Semantic Web Company are now part of GraphWise. Okay, this is a group to support these solutions. But we have also some property graph and native graph platforms, mainly for analytics or for graph exploration, for clustering, these kind of things. Neo4j, Tiger Graph, Stardog, or Cambridge Semantics are some examples with on the GraphDB, for if you already heard about it. Of course, we have the enterprise giants like Amazon, Microsoft, Oracle, or IBM, with integrated solutions, often blending knowledge technology with cloud AI services. And then we have emerging vertical players from DataVid and Clever to Flurry and Apply AI from Opus, exploring different domain-specific use cases, performance optimization, or sometimes AI integrations. So for your information, we already discussed a lot with the partners to identify what could be the best technologies we want to use through our GRAPHIA project. So for the moment, we decided to use Virtuoso at the core and then to perform some experimentation through Clever, which is, I don't know where, here. So we will try some experimentation based on it. If you want to get the details about why we have decided to use this solution instead of the other ones, I can share with you all the details, all the report, all the evaluation we performed together during the 6 previous months about it. So now, enough theory. I propose to build one knowledge graph together. My idea today is to be more concrete with you to understand better what we are really preparing behind behind the slide, behind the theory, behind the concept. So I really want to share with you concretely some example how we are building it. Of course, some of you already see how Jan is organizing the competency question in his methodology, but also I would like to share with you how we can put some data in a knowledge graph and what is the meaning of reasoning in this context. So I propose to follow this short step. Of course, this is something very simple. It's just for illustrate a little bit what is really a knowledge graph. And as a big tennis fan, the theme is imposed. That's why today I propose to build the tennis knowledge graph, which is a knowledge graph about the ATP players and tournament from 2024 to 2025. So then I will share with you my screen because I have some external tools to share. So I will try to do it. And from now, but maybe just to explain the steps. So first of all, we have to define a scope domain. For GRAPHIA, this is the SSH landscape. In our example, it's already done. This is the tennis landscape. Then we have to design a basic ontology. We have to define what question do we want to answer if we want to build a useful knowledge graph for us. So the competency question. We have to write that ontology in Protégé. We have to write it concretely in a tool dedicated to the semantic artifact. So I will share with you protégé, because some of you already heard about it, but it could be interesting for us, I suppose, to see it for real. Then we have to add real-world facts, I mean the raw data. We have to put the raw data in the graph, and then we want to query and explore the graph using some real Sparkle query to see the result. So this is my proposal. Let's keep it simple and visual, and by the end, I would like to let you ask some questions and maybe dive into the details if you are interested. The idea behind is to share with you, you have the link in the chat, you can open also Microsoft Teams if you want to see the correct, the correct spreadsheet. Just to explain, as you can see in the competency question file, the first step to build a knowledge graph is to identify what we want to explore into it. That's why we have to identify the competency question, which are the different kind of interaction we will have with our knowledge graph. That's why we have already some sessions through Work Package 2 to do it, and we already initialized an important set of competency questions, and this is the main purpose of the next meeting for today. But just to illustrate it with a simple example here, yes, please, Susan. Again, the link of the document, yeah. Okay, so when, for example, in our context, we are building a knowledge graph about tennis, so some question relevant for us could be, okay, which tournaments did a player, so for example, Alcaraz, Sinner, Djokovic play in 2024-2025? Who won which tournament? How many matches did a player in which year? Which player reached the final at this tournament in, for example, 2024 or 2025? Please, I would like to list all matches between player A and player B. On which surface did a player win titles in 2025? So this kind of natural language sentence to help us to identify the user needs of a knowledge graph. This is the first part of this exercise. And then we have to identify the type of answer we want to collect through this competency question. So, for example, when I ask to my knowledge graph which tournament, I won't have as an answer a list of tournaments. For example, Carlos Alcaraz play in Roland Garros in 2025 or Wimbledon in 2024, 2025 also. We won this tournament. We expect as an answer a player, which is a concept in our knowledge graph. For example, for Roland Garros or in 2025, the answer is Carlos Alcaraz. So it could be, it's a very simple example, but at the end, exactly what we are trying to do in our SSH landscape. But it's obviously much more complex because we have to deal with all the specificities of a SSH domain. We have a lot of different concepts. We have a lot of different needs. We are addressing a lot of different dimensions. So that's why, at the end, this is the main idea. Build the competency question. And then, so let me share with you the next part. Okay, so then now we have our competency question. We have to define our ontology and to illustrate, to extract from this competency question the different key concepts and entities we have identified through this user needs. And the result could be something like this. So as you can see here, this is a first version, a first draft of our model, of our knowledge graph. Let me explain a little bit more. At the core, thanks to the competency question, we have already identified three main classes: a player, a match, and tournament. These are the backbone of our graph. each player played in one or more matches, and each match has participants, typically 2 players. This bidirectional relation is explicitly modeled to allow queries in both directions. Okay? Every match is part of a tournament, and conversely, the tournament included matches. Again, this duality helps for flexible exploration. On the outcome side, each match can have a winner and optionally a loser. Important when we want to compute statistics or filter by results. Similarly, each tournament can have an overall winner, either asserted directly or inferred from the final round. This model also includes contextual properties. Matches are linked to a round, and tournaments are characterized by a surface and a location in this example. One important relation is shown here as a dashed arrow, just here, up between player and tournament, because this is not directly stored. I won't put this relation explicitly in my model, and I will explain why. Because I want to derive this relation from the chain played in and part of. The idea behind is, okay, we don't have to put all the relations between all the entities. We don't have to denormalize everything, because at the end, I could put a rule to say, okay, if a player played in a match and this match is part of a tournament, okay, so maybe we can deduce that this player played a tournament, which is this tournament, you know? Okay, I will show you how we can ask to GraphDB to do it for real. I mean, to infer more data just from our ontology. Okay? This is one of my objectives. So, okay, we have a model, but it's... Yes, please.
No, it's sorry, it's a question, Julien. Here in the example you show, could we add, for instance, the public, the journalist, that can be related to a match? Okay. So then, how do we define where to stop? You know, because in a knowledge, what I see is that you can put relation over and over, because if you add the audience, you can add also then the journalist, and then the marketing, and then you know, and so where do we stop? You know, how do you define that?
This is the whole point of having competency questions and scoping, because you can go infinitely in granularity. So you have to decide which ones you would like to focus on first, so you can come up with that model, which is an ontology, right? And then if you want to add more questions like, oh, I would like to know which journalist covered, and in which articles, in which journals, and so on, you can then extend and ask the proper questions so that you can define the model. So that's what I was trying to convey this morning. Ontology building is an infinite work, right? So you have to scope the work, which is why this example is perfect. And your question is even more. Thank you.
Thank you, Suzanne. Thank you, Jan. And it's exactly the scope of competency question. And this is the result of the previous spreadsheet I have shared with you. But again, it's a slide. So concretely, now we have to put this diagram into a real semantic artifact, a real ontology. So I will show you how we can do that. So of course, we can do it manually through directly in file, but we have some dedicated solution to build for real this diagram. I mean, for example, Protégé, but we have also Workbench, and this is the purpose of the Lumis platform. We want to connect all this tool about the semantic artifact lifecycle through this component we share with you this morning. So let me share with you the Protégé instance. So I will try to do it. Okay. Okay, it works. This is Protégé. This is a software where you can put, as you can see, some through the different tabs, entities, relations, rules, some constraints also. So of course, I have already prepared the work because this is to facilitate this presentation. But as you can see, I have put some metadata on top of it. Okay, this is the knowledge, the tennis knowledge graph ontology, a minimal, all, which is the format for the ontology, vocabulary for player, matches, and tournament in the scope we have defined to support the demonstration of competency question. And also, we can see here, I have put all the main entities described in the previous model, from the diagram, the main entities I want to put in my ontology. And for some of them, I put some rules, some constraints. For example, yeah, a tournament, it's exactly a subclass of 1 year. Yes, yes, a tournament is scope to 1 year. We have each year one tournament, only one Roland Garros by year. I mean, you can put this kind of rule, but also we can. I don't remember. Okay, we can have some fixed instances. For surfaces, we have clay, grass, hard. This kind of rules. Also, run. Okay, this is the same thing for one. We have round of 16, 32, final, quarterfinal, semi-final. Player. Okay, we can explain that. Okay, we can put some disjoint rules to explain. Okay, this concept is not the same as the other one. If we want to help to support the reasoner to be more precise, we can put also some constraints. So in a match, we have at least 2 players, and a match is always part of a tournament, in my example. But this kind of constraints, and you will see it will help us to navigate and explore the graph through some rules. And also, as you can see, we have the relations, the properties. So as location, as match loser, as match winner, as participant, all the arrows we have seen just before, as round, as surface, as tournament winner. So you have to define what is the domain and what is the player. So the 2 parts of your arrow, of your relation. And then you have also some properties, I mean some metadata about the entities you want to define if you want to add some metadata directly in your knowledge graph. So for example, the round name, the location name, the date of a tournament, etc. Okay, so this is the protégé perspective. But at the end, when we will save this semantic artifact, it will be translated, into something like this. Okay. I'm trying to orchestrate everything. So, okay. This is exactly the same thing, but from an editor point of view. I mean the file, the raw file directly. Sorry, it's not really easy to see, but this is exactly the same data as we have seen just before in Protégé, but written in the OWL format directly. But you have exactly all the rules written in the Protégé solution. So yeah, it's just to show you for real that at the end we have some triple, as you can see, and we will retrieve all the information. So for example, when we are defining the property as a match winner, it's between a match and a player. Okay, just to illustrate that everything is at the end some triples. And you can see here the ontology layer at the top of our knowledge graph. But for the moment, it's just the ontology. We don't have the data. Okay, we don't have Carlos Alcaraz, we don't have Sinner, Djokovic. We have just the meaning okay, the rules between the concepts. So now we have to add the data to prepare the data also for our knowledge graph. So just let me know. So okay, just here. So okay, another file which is this one. Okay. So the main purpose of the data acquisition platform, as we have already explained just before, is to collect, to harvest the data from the data sources, in our case in GRAPHIA, from the different use cases, from the pilot, but also from all the data sources already harvested by GoTriple into our knowledge graph. Okay, so we will apply some transformation on the data harvested in order to translate this data into some entities and relationship, I mean nodes and edges, in order to be compliant with the structure of a graph. Okay, so for the moment, we have some workflows in order to put the SSH data into GoTriple, but GoTriple is a search engine, so now we have to translate this data into triple data in a triple format, which is the format compliant with the graph structure, exactly this kind of code. So as you can see here, now we will instantiate the data. I mean, for example, here I will put as the data Carlos Alcaraz is a player. Now we are in the graph layer, I mean in the second level. I will use my ontology to declare, to instantiate the real fact, the real world entities. So now, okay, Carlos Alcaraz is a player, also Djokovic, Yannick Sinner, Medvedev, and I will also add all the location, the real one, so Paris, London, etc., etc. Okay. Also, I will add all the tournaments, Roland Garros, Wimbledon. I mean the instance by year in our example, etc. And I will also add all the finals, all the matches available, etc., etc. So I just have to use. Oh, sorry. I just have to use the model to put this raw data into my graph, following the properties and the entities already defined just before. I don't know if I'm clear. Yeah. Okay. So then, yes, please, Giovanni.
So the file that you just showed us before, was that directly exported from Protégé? Okay. So no.
No, I will try to share again. Okay, so this file. Perfect. The previous one, the ontology, is an extraction from Protégé, because I need a software, a solution to put my concept from the diagram to this file, and to do it, I use Protégé. But for the real data, I mean all the instantiations of my model, I will use the data acquisition platform from the data sources to translate this data into the compliant model, which is this one. But here we have a lot of data to harvest, you know, because, okay, the ontology, we have some 100 concepts, entities, maybe 1,000 of relation defined properly in our ontology. But at the end, the amount of data is very, very important. We will, for example, in the Matilda platform, we have more 300 millions of entities, more than 1 billion of relationships. So, but we have only 3 entities: works, author, and text. That's all. That's why this part is made by the data acquisition platform, and this is why we have a lot of issues to address to be sure that we are robust, we can scale, we can reindex everything when you need it. So it's the purpose of our current discussion with the technical teams, but this mainly to produce this data. I mean, in a graph structured format to be put into the graph. Yeah?
Thanks, Julien. I've got a question. I'm maybe ahead of myself. If there are differences in terminology, say, so you call players players, but if I said athlete, where would that be caught in the process? Is that in the translation, or can the knowledge graph accept, you know, like synonyms or similar terms and understand that they mean the same thing? Does that make sense?
Okay, so maybe two answers. First of all, okay, we have to when we are harvesting data from data sources, we have to identify the player. Okay, this is a player. It's not a tournament. So this is the disambiguization part. We have to identify the named entities into the file. So this is a first challenge. Okay. So then we have to be sure we can also reuse some existing definitions. So as you can see here in this part of the file, we have another properties which is same as. And here you can see a Wikidata entity. Just to explain, okay, we already identify Carlos Alcaraz in Wikidata. This is the same entity. So thanks to this kind of property, we can say, okay, I'm sure that this player is the same Carlos Alcaraz we have in Wikidata. Thanks to this kind of relation. This is another way to link and to be interoperable when we are trying to identify a specific concept in this ecosystem. I don't know if it's answer you.
I mentioned that briefly this morning in the intro. That's called mappings. So you can actually map different models. So if you want, you can integrate that into your ontology, or you can externalize it as a relation and say, well, this, like the Julien has done, this is the same as the entry in Wikidata, but it could be in another ontology, and you would say, this is the same class. And then there are different levels of relations you can provide. Sometimes you get a concept that would have a broader meaning than another, and you can specify that so that actually you know that it's not exactly the same as, because same as is very strong here. It says that they are identically the same, they are the same entity. So if it's not the case, you can add some nuances in the relations and use some of this. That's why we're working a lot on this mapping aspect, because you have to formalize them on, let's say, in a standardized way, because otherwise it's becoming messy. But then you can connect different knowledge graphs together by doing this mapping. And I'm going to talk later on about the SKJ-IF, which is the Scientific Knowledge Graph Interoperability Framework that does exactly this, connecting OpenAIRE with Open Citation with others. And that's what we're going to do as well. It's just, let's say, I'm already selling my the next session, but this is where we're going to discuss in the design of the GRAPHIA ontology.
Thank you, Ian. Any other question?
Julien?
Yes?
There is a question in the chat, but I also wanted to ask something, so I'll just jump in. I'm sorry, I don't know who was just speaking, and so I cannot address them by name, but I was wondering if this is also going to be applied to translated terms. Somebody just mentioned as well, how are you going to manage this in multiple languages, if that's the plan? And then there are two questions in the chat, if you want to have a look and address those two.
So maybe I can address the multilingualism. So you can eventually use mappings. There are other ways of doing that. When Julien, can you show the turtle file? Yeah. When you see, you have the RDFS label, and then associated with the name, like Carlos Alcaraz, there is the language used, so it's in English. And so actually you can even create one class with different translations of the same terms, and you can even specify the language that is used with the common standardized acronym, so that you can actually use that for multilingualism. Of course, you can also do that through the mappings, but that might be also quite cumbersome.
If I can also comment on this, I think an alternative approach will be to tackle this problem not at the moment of modeling, but in the moment of querying the knowledge graph. So the question of synonyms, I think, will also come up with a competency question. So not necessarily the same terms you have them in the ontology, and the same for the languages. So LLMs kind of rich multilingual knowledge and also ability to find synonyms and translations. So I don't think we necessarily need to solve everything in Indian ontology, especially if we're going to use kind of a LLM-based approach for querying. That might be solved also there, or might be kind of complementary.
Totally agree on that, because that's pretty cumbersome to do this by hand, right? So now we have large language models, that's their job, so that helps the thing, yes.
But aren't we going to actually translate the vocabularies for Go Triple like soon, during some of the events? Sorry to ask that, but I had that feeling that it is going to happen.
I also add about translation. So I think for social science, it's okay to use LLM, but for example, medical terminologies, I don't think an LLM will work in that case.
I can answer to Magda. So there are some of the ontologies of GoTriple already multilingual, but actually during Atrium, we are doing an hackathon to translate all the concepts in the label or describing the concepts in multiple languages. So it's happening these days. It's, can't remember, next week possibly? Yeah, so it's happening these days. Of course, it's just the labels.
Side note, we have a session tomorrow which would go into this, like translating, like if you have player in English in your ontology, but you write in Spanish, I guess it's jugador in Spanish, it's going to automatically translate it and give you the right result.
It's jugador. To finish this demonstration, we have to put all this data in our knowledge graph, but because for the moment we just have some files. So to do it, in this example, we will use GraphDB. So I will open it. I will open the GraphDB workbench. So as you can see, I already declare the repository where we want to put data. I mean the files. So, okay. I will do it. You will see it's very simple. I have already selected the knowledge graph, okay, the repository. So now I will click on import the file. So I will just select two files as a reminder, the ontology, but also the data, okay, the two layers. And then I will import this element just before, let me check something. I would like to trash the repository. Just 1 second. Okay. Now I would like to show you something. Okay, I will start from the beginning. Okay. And as you can see, when we are initializing a repository, I mean a knowledge graph, we can select if we want to be able to reason on the data, because, okay, this kind of rules allow us to infer new data based on the ontology we have designed. As I already explained, I don't have put explicitly the link between a player and a tournament. So if I want let the solution infer new data, I can I can put it as a configuration or not, because of course it will consume resources to do it. It's computing, so we need some resources to apply this kind of inferences. But just to show you the differences. So okay, I will create this repository without any reasoner into it. Okay. So now I will import the file we have already seen. Okay, just like this, import. Okay. So now it's okay, it's done successfully. So I will show you an example. So, okay. For example, is Sparkle query, but related to one of our competency questions. The competency question number 2 was who won a tournament? For example, who won Wimbledon 2024? And in Sparkle, sorry for the size, it's something like this. Okay, select winner where Wimbledon as tournament winner, someone. Just something like this. It's very simple. Okay, so I will try to apply it directly through GraphDB. Sorry. Okay, so just like something like this. Okay, so as you can see, I will try to run this Sparkle query, and the result is, okay, it's Yannick Sinner. Just to explain, at the end, the main objective is we want to translate the complexification into Sparkle query to test the consistency of our graphs, just to be sure that we are addressing the user needs. This is the main methodology we want to illustrate through this approach. But also, I will try another one, just to conclude, sorry, which is, okay. Okay. Just like this. Okay, so now the question is, first competency question, which tournaments did Carol Alcaraz play in? So remember, these properties, play tournament, and I will run the query, no result. I don't have any result. I don't know, I cannot answer this question, because if you remember, as you can see here, okay, here, we don't have put this relation into the graph, okay? We don't have it. I don't put this property in protégé. So now I will try to rebuild my knowledge graphs with a reasoner, because I have said in my ontology, okay, if we have a player which played, we have played a match in a tournament, so by deduction, okay, this player played in this tournament, you know? A then B then C, so A then C. So we will try again from scratch. So I will remove the repository because it's faster to do it like this. Okay. This time I will select one reasoner. So all two, for example, is the name of one of the reasoner available in GraphDB. Okay, create. So now I have to import again my data. Okay, okay. Okay, and now I will try again my request. So now I have some results. So which tournament did Carol Alcaraz play in? Roland Garros 2025, 2024, Wimbledon 2024, and the US Open also. This data doesn't exist in my files. This is a powerful feature provided by this kind of solution in GraphDB Virtuoso, the knowledge graph. So I'm running late. I have a last thing to show with you, but maybe we can skip the mirror part. I don't know if, yes?
I was wondering which is the limit of LLMs in making inferences based on the information which is in the graph, implicit information. Can you just go for a second back to the diagram? Yeah, exactly. So you, in the first exercise, we didn't put the played tournament relationship, but we just has tournament winner, which implicitly assumes that that player played that tournament. So can the LLMs that you build on the base of the knowledge graph do these inferences? Like for instance, let's say that we didn't make the question about Alcaraz, but with Sinner. So you ask, did Sinner play the tournament? And the answer that we get is, I don't have clear information about that, but since he won that tournament, he did play it. So that could also be, I don't know, an interesting feature of the GRAPHIA graph. Like I assume that since our data is very heterogeneous, since we are covering this like huge world of domains, which is the SSH domain, we might have sparse relationships. Like we have very dense knowledge, very dense regions of the graph, and very sparse regions of the graph, in which we have maybe very specific relationships that have a lot of implicit meaning. So can the LLM go in that region and maybe be transparent about this, like in the example that I did? Like, I don't have this information explicitly, but given this triple, this RDF, I can tell that very likely this thing is true.
I won't spoil the content of the presentation tomorrow, which is based on LLM between. So maybe because yes, because an important part, as you can see here, is okay. We have some feature which are okay. Now I want to talk to my graph with LLM, but how we can do it? And this is the purpose of the Automa presentation for tomorrow. So, you want to add something, Matteo? I don't know. Yeah, but it's a good transition for this upcoming workshop. So I don't know, Michel, I have 5 minutes to conclude, or? Yeah, it should be okay? Okay, thanks a lot. Because I really want to share with you the last part of our presentation. Just before, what we have seen is exactly the work we are currently doing with Work Package 2 through the complexity equation, through the GRAPHIA ontology, and we will dive into the details just after this workshop with Jan and the rest of the team, so in 30 minutes. Okay, so very quickly, okay, now as you have seen, I have performed some requests, I have made some interaction with my graph, but thanks to Sparkle query, it's not really user-friendly. So now, how we can explore, how we can ask something to my graph, or I can explore my graph. What are the ways to explore the graph, the knowledge graph we have built? So we have seen that, okay, we have some private Sparkle endpoint to do it, exactly as we have seen through GraphDB, thanks to some Sparkle request. We can do it. We have some workbench, a kind of console to explore our graph, exactly as we have done together just before. Also, we have some public Sparkle endpoints. Maybe you have already tried it, thanks to DBpedia, Wikidata. It's exactly the same kind of console. You can put into it some Sparkle requests in order to explore the Wikidata knowledge graph and the DBpedia knowledge graph. Also, Clever propose some interesting demonstrations to do it with some performance quickly. So you have the link in the presentation. It's also the case for other kind of graph, for example, property graph like Linear4j. We have a console with requests in another language, for example, here Cypher, to explore our graph in different ways. But now we have also very interesting approaches, and I would like to highlight the first one, which is SparNatural, already shared by Luca recently. So, okay, as you can see here, it could be another way to allow the user to explore the graph since this kind of, tools. Maybe we can offer something like this for our GRAPHIA exploration layer. So as you can see here, the idea is to help the user to build the Sparkle request, because it's not easy to write RDS, triples on Sparkle query. It's a specific syntax, a specific vocabulary. But here, as you can see, the idea of this interface is to help you to build the request based on the entities we have in our model, in our diagram, in our ontology. So it could be something useful for the Graphia end user, maybe, to use this kind of approach to help us to explore our knowledge graph at the end. So yeah, it's an example of user-friendly interface we can deploy in our context of Graphia. We have also some other guided query interface. So Sparklist is another one, but as you can see here, it's not really. Okay. You have some UX component to help you to identify better the entities you want to explore, but it's not really maintained, and it could be used as inspiration for our purposes. But also we have some Sparkle client family libraries in order to build our own integration. And as you can see here, it's an example from another project we have developed with FoxCub, which is a discovery platform to explore some photos on cartographies. And thanks to specific Sparkle query, you just have to select some. You just have to select some object in the interface in order to identify, for example, here all the maps available in our database which are overlapped together. So you can select directly in the, for example, in the map the boundaries of your analysis, something like this. We have also some tools to do it. And then, of course, the idea is we could also talk directly with our graph thanks to the last chat-based innovative approach, more or less. But we will see tomorrow what we could be, what we could do through this kind of approach, thanks to the workshop about it tomorrow, as we have already said. And if you are interested, there are also some other tools listed by the Wikidata community. I put the link in the presentation because it could be also interested if we want to explore other approaches to explore our graph. So that's all. And just very quickly, in the mirror, please, if you can share some feedback about the approach you would prefer to explore our knowledge graph directly in the mirror board, just to let us collect some feedback about it, because it could be very interesting to see if there is already a trend or not at all. And then also, if you want to put some feedback about this demonstration, it could be very useful for the next one. And yeah, that's all for me. Thanks again. Sorry for the issues, but yeah, I try to do it.